Mm, okay. So yesterday we talked about the introduction to 3D surfaces or 3D objects generally in AutoCAD. For our semester, that's what we are learning. We are learning 3D AutoCAD, not primarily 2D AutoCAD. So um, those videos I did, like I will say again, especially this week that won't be around, watch them as a master how to draw before we come back so that we won't have to be thinking about all those things again. So our primary focus is 3D. So I'm going to keep to that so that we have a lot to cover. Um, we have just barely 2 months to go. That's why I increased the class time. Um, so the grace of God will catch up. All right, douchebags are lying here. I will just continue from here that we did yesterday. So open that file, simple 3D tools. Mm, Open the simple 3D tools in your uh, the folder I gave you. So go to file, open, and search for the file. That kind of thing I did yesterday, I don't think I'll do it again. I got home around after 10 and instead of me to go and sleep, went to go and wash clothes. Yes, because I do other things apart from. Yes, I did that. I finished washing around after 12. I slept, still woke up by 4. So my body is like somebody caught me and I was in in a fight with the Hulk. So all this was messed up. And Jason will be happy for that kind of thing. Like, I'm feeling so. There's this leave like this, I'll sleep like this. Okay, all right. So back to us. So do we have the file open? Yeah. Okay, so I'll just run through what we did yesterday. Remember our navigation. Rotate is shift and middle mouse, or let's say orbit. Um, then to zoom or dolly is roll your middle mouse. Then to pan, click and drag your middle mouse. Okay. So yesterday I described the difference between an extrude and a press pull. And I said generally an extrude extrudes out a complete shape. Extrude out a complete shape. It doesn't cut off like this circle, for instance. If I click extrude, it will pick either the rim of the circle or the circle itself. So uh, if I pick this rectangle, it's gonna pick the rectangle, and if I pick this line, it's gonna pick a line. So it's not going to cut the selection; it's going to pick the whole shape itself. And I said it has two modes. It has the surface mode and the solid mode. Solid mode is the extrude bringing out a solid object. solid objects. Let me turn it to bring out a solid object. So the surface mode, on the other hand, surface mode will bring out, will extrude the line and leave an empty cap in the face there. So this is extrusion with the surface. This is extrusion with solid. So solid just brings out the complete object, capping it, while surface brings it out from the edges itself or from the boundaries and extrudes or creates a surface generalized or generated from that. Okay, so do that. Okay, then I said the press pull. The difference is that the press pull will select wherever there is an intersection. So if I pick here and move, it creates the intersection, creates an intersection. Okay, so that is a press pull. It creates surface geometry from anywhere we have two lines. So basically, they are working. They are 3D editing or object editing tools that generate a 3D surface from 2D objects like lines or circles or rectangles or whatever shape, 2D shape you use. Okay, so regardless, even if it's a polygon tool, describe a circle. Okay. So even if I have this object and I do a press pull with it, it's going to extrude out just that section of the drawing. So is it something close to that? So this what press pull does. It helps to cut out wherever there's an intersection. It helps to bring it off. So another thing the press tool, as a press tool, the press pull does is it can help you create holes in certain shapes. Like if I was supposed to draw, let me do this. If I use extrude now and brought out this guy, let me turn it to shades of gray and I use extrude to bring out this guy. So if I want to cut a hole here or here, I can use a press pull. So there's something about coordinates that I'm going to show us also today. It is in case the situation where I want to draw a hole here instead or here. And how I say AutoCAD likes to work. So basically, let me use the circle tool, which is this guy, and click to drag a circle here. Something like this. So let's say I want to create holes or depressions with these objects here. I can't use extrude to do that. I can only use the press pull. The way the press pull works is it has a direction. It's in 3D modeling. I talked about that some time ago when we are doing basics of 3D. I said every object or every element in 3D, be it a vertex, be it an edge, be it a face, a polygon face, it has what we call a normal. We call it normals, normals. Normals, yes. It's called a normals. What that means is the correct facing point of that element. So when you put a point, I mean a vertex, or you draw an edge, or you draw a polygon face, there's a normal where that is where the face is facing or the vertex is facing. It's usually determined by an arrow. So polygon normals, I'll open my eye and show it while my eye is opening. I'll still talking about that. So normals help you in modeling. Basically, if you create an object and the faces or vertices are not facing the normals, you end up having what? How? What's going on? Oh, you don't do now, not yet. Hmm. I'll do that later with that. So generally, the way normals work is if your objects are not facing in the right direction, when you apply a texture, it will not apply correctly. It will apply like the back of the texture, kind of the back face of the texture. So you always want to make sure all your elements are facing normals. So why I'm talking about normals is the way press pull works. If you are pulling or extruding in the normals direction of the object, it will extrude, create a press pull. But if you go in the reverse of its normals, it will trim off that portion. So like now, if I take my press pull and come to this circle here, this one, calm down now, just pick it, don't quarrel. And I click that to pull. Oh, I didn't click on the press pull. Let me draw the circle again. So press pull, and then I pick on this guy. If I pull up, it's going to pull the shape up, right? It's going to drag it up. But if I go downwards, like in the reverse, going down, by clicking and accepting this, it's going to create a hole instead through the object. So if I want to create a hole through this object the same way, if I go up, it will extrude. But if I go the reverse way to create a hole, so I can have a hole and I can have an extrude option there. So that's how press pull works. So to make holes with press pull is easy because it's just a matter of extruding reverse, the opposites of the normals, where the normals of whatever you're extruding is facing. So the that's how that guy works. Yeah. So it's very important to note. Now, what if I want to draw a circle here? And I think I talked about it yesterday. I just want to reinforce that idea. Right now, the way AutoCAD works is it will draw only on the YX plane, so preferably what we'll say the Z plane. No matter what you are drawing, it will only draw it on the Z plane. So if I want to draw a circle on this guy and I pick my circle here and I click to drag, it's not going to draw based on that until I trigger something called the this thing we did yesterday, that's view plane, or I trigger on my dynamic UCS here, this one that we added. So if I turn off dynamic UCS now and take that circle and draw, this is what will happen. It will draw a circle on the floor of where the XY plane is. But with the dynamic UCS on, I can draw my circle even here. Let me see. Am I on the circle? Yeah, let me escape. Here's my circle. That's my circle. So my dynamic UCS on. So whatever plane I am facing at that moment is what is going to draw on. So if I rotate here, as I want to draw on this plane, I can click and drag and to draw a circle there. If let me turn it on back, I can come to this section and draw on this plane and pop. So the dynamic UCS allows you to pick whatever plane is possible or is available to you to draw on. Without that, you can't draw on the sides of an object because probably I wanted to do a press pull for this guy and bring this side out while push this one inward and while push this one inwards as well. So I probably have those kind of options or drawings or holes around it. So it's not going to be possible unless you are using your dynamic UCS or you change here to view whatever option or whatever face you want the 2D drawing to be. Because basically everything that we're using this um, circle, rectangle, lines to do, these are 2D objects, which mean they have to be drawn on a plane, a specific plane. And the original plane or the aboriginal plane is the XY plane. So that flat, the grid, where the grid is lying down, that is the plane. Okay. There's another way you can draw your circles by adjusting, like I told you, rolling these guys here, your UCS icon, like the Z is pointing up now. If you click on the icon, you can use it and swap the direction so that the Z is now pointing in whatever direction you want to point out. But I escaped it, don't worry. So it's just some other complex points. You can also come here and say, okay, I want to switch to front. And now the grid is pointing front. The Z is facing here. So if I draw, like this, it will draw a circle on that front. I can switch to uh, left, and the grid is now facing this way, pointing that way. You can take your circle. This time, if you draw, it's not going to draw facing that front, it's going to face this direction. So, and then if you want to go back, just go back to world. So, but now you have two circles facing um, in weird positions. So this is the first one. This is where the second one has gone to now. So that's how, that is what those plays are. So to be smarter at work, we prefer to use the dynamic UCS, because when you do things like this, it will just throw your shapes to some places that you don't understand where they went to. Okay. All right, so that is for press, pull, and extrude. Very simple. Those are the two primary ones that we work with. The next object we're going to see is called the, well, in some softwares it's called revolve, in some softwares it's called lathe. What it's doing is just making a 360 degrees shape, like a continuous shape. So we find it here. When you click on this extrude, you see revolve. In a software like Cinema 4D or 3ds Max, which we'll be going into, is called a lathe, Lathe. Yeah, a lathe is a device that potters use. That thing, when they are trying to create a pot that is spinning, they just put the clay there and put their hand, the thing will just be spinning and they'll be carving this thing. So that's a lathing machine. So it's called a lathe in some software, like I said, like 3ds Max, Cinema 4D, because it's emphasizing that machine, that 360 turning. So, but in Maya and in AutoCAD, we call it revolve. So it's still the same tool. It's a NURBS modeling tool. When we talked about modeling in our base of model, I said there are how many kinds of modeling? How many modelings did I mention? Was it four, five, three, two, six, four? Good. So I said we have NURBS modeling, polygonal modeling, subdivision modeling. We have the volumes from the modeling. So this is a byproduct of NURBS modeling. NURBS modeling, NURBS, meaning non-uniform rational base splines. That's is an acronym, NURBS, NURBS. What that is saying is it requires splines or paths to generate a surface. We saw an idea of it in Illustrator when we did the 3D revolve. You create a profile and then you revolve around it, or you create a profile and then you extrude it, or stuff. Then when we did all those packaging bottles and the rest. So that's generating a surface from a path or a line or a spline is using a NURBS modeling technique or a NURBS surface. And these are the four basic NURBS surfaces that we have here. So we have the extrude, we have the loft, we have the revolve, we have the sweep. So I'm going to show all of them with these drawings. Yeah, so we'll start with the revolve. So what the revolve is going to do is it's going to take this path and make a 360 degrees turn with it. You will like what shape I created here, because the profile I used here is quite interesting. So the profile I used is quite interesting. So I'll go to revolve. So the first thing you do when you select the object is select what you want revolved. So this is what I want revolved. Once you do that, enter. Since my right click has been triggered for enter, I can click it. Now it's looking for your start and end axis. That's what is it revolving around. That's why I drew these two lines here. You can revolve it around itself, just like we did in uh, Illustrator that time. You draw like a bottles out profile, and then that middle point it will revolve around it. Then you can offset it. Good. The same thing here. So you can revolve it around itself by specifying the end point. So if I click here and click here, it's going to revolve around that line. If I click here and click here, it's going to revolve around that point. So let me start by revolving it around this red line. So I'll specify the first point here and then the end points. Once you specify the end points, you have a shape. It's a 360 degrees turn. So let me make it halfway so I can complete. So this is the results that you have. So that is the profile I got, this the call. And then it's now revolving around. You can see now that red line is like the center of where the object is revolving to. So it revolves 360 degrees around itself. Okay. So that's the option there. Just want to show you. So can we try it ourselves? Click on this thing. Right now, because I stopped it, I want to complete it. So I gave you guys a list of shortcuts. In case you can remember, when you want to see the properties of your objects, Control 1 will show you the properties panel. So like now, this is the revolving angle. I stopped at 305 degrees. Okay, so can go back to 360 degrees to close it up, or you reduce it less. So I just did it halfway so that we can see what shape it creates. So remember, Control 1 is for properties. If you don't remember the shortcuts, the manual is there. I wrote those basic shortcuts there. Let me undo this. So let me do it again. This time I select the object. I'm going to revolve it around this green line. So I click here and click here. It creates a different kind of shape. So this is the kind of shape it creates because of the way the profile is placed. So it's going, instead of going this way now, it's going this way. So it creates something different. So, and the central point is now that green arrow there, or green line. So that's the central point there. Sir? Okay. So try it out. Let me see what you get. What happened? Your system is doing someone. Oh yeah, come and do it here. Come and do it here. Let us record you and see what you. No, come and do it now. Okay. Okay, I'll sit. Uh-huh. That would be a very weird object you're going to create. Jesus. Why is you don't understand? You're supposed to create a profile, not alter the human nature. Can you put this point here? What's wrong with all of you, sir? What do you want to do? It's not going to do this here. Because it's like, how do you want it to turn? In the properties, you see the angle of revolve. Let me let me do this one again. You know, so let's say this one now stopped here. So control one. So select the object. Otherwise, this one is just showing the general properties. So select the object. Then you will see under geometry. Or it's slowing down. Or it's slow. Okay, sorry. Under geometry, this place here, where the angle of revolve. So whatever angle you had there, 360 is the highest, obviously. So you can change it to 360. Get back. The where? Which red part? And here. No, AutoCAD, if you are doing something that is not sensible, it will not do. Well, I told you now, I thought I said you're trying to create something, not trying to alter that. There's nothing, bro, that is not new thing. That is just, okay. Not the object. Is that's the orbit you're seeing now. Shift and middle mouse. Middle mouse. Yeah. Jason, let's be logical. Wait, no, first, let's look at it. If I click here and click here to create a revolve, the question now, let's be logical. How will the thing turn when the angle of turn is within itself? How will it turn? Because the line is even crossing itself. It will not work. I'm telling him to not work since he likes to argue. So you pick here. See where you're crossing to. See where you're crossing to. What do you think? You can tell you that it's unable to revolve it. It can't. Now, where will it pass? Is it a winch? It's not, there's nothing dumb about it. Even normal AI. No AI will tell you, sorry. If you use this line and you use this line, yes, it will revolve because it's not crossing the object. You can't. I want to. You have swept the sweeper. Have you swept? Yes, that's swept. Okay. Yes, and then press enter because you have to always press enter. Then you now select the path you're sweeping it along. So if I'm sweeping this polygon, select the sweep, I sweep this, select this guy, I press enter, and now sweep on this path, and the object automatically goes. So let me make it more interesting. Let me undo that. The sweep, just like every other thing, like how the extrude had and the rest, we had the command line. So, like I said, in AutoCAD, always take advantage of the command line. So now I sweep, I pick the object, right? It's asking me for a mode first. So then if I click enter, it's asking me for the path it's sweeping on. How are we doing? Is it based on alignment or base points or based on scale, or based on twists? Yes. And select the path. So if you do scale, for instance, scale, well, you can give a scale like anything from 1 and above. So let's say 3, 4, 2. What that means is the sweep will start from whatever the size of the profile is and increase as it's going. So if I put like a scale of 3, for instance, press enter and select this guy, it will start sweeping from the size and increase by scale of 3. So to get larger at that sector there. No, if, unless it's an AutoCAD design, like all those, like something just funny looking technological things. When it's normal modeling, it's not necessary they will use AutoCAD. They may use Maya, they may use 3ds Max, but as long as it's 3D software. So if I want to twist, that let me escape this. I want to make, let's see, I want to copy, I want to make copies of this and specify base point. Just make, I just want to make some copies. All right. So sweep. If I pick this guy, before I have the mode, right? And the mode I can do solid or surface. So coming from extrude already, what's solid and surface? You should know what the differences are. Surface will sweep, but it will sweep with a cap, a hole. That's in, like based on the surface of this guy. So just like we did the extrude, it will just bring out a line with a hole inside. If it's solid, it will make it a solid object. So if I do surface, for instance, and I now select the path, it will create a sweep with a hole because the object or the 2D object did not have a covering. It's just lines. There's a hole there. So it just stretched out the edges of the profile along the path. So that's different from you sweeping, changing the mode to solid. and then selecting a path. It will now cap that hole. A solid will make a solid. A surface will only pick the edges of the path, I mean of the profile, and run across. I didn't seal up anything. That who? The shape. It's the shape that is sweeping now. So what is this up here? So I was saying the other one we did, let's say I've said the surface. So if I did, we did scale before. So let's say I do twists, and my expression, let's say I wanted to twist 360 degrees two times, like 720. So right 720. Yeah, that's 720 and twist this guy and twist, create that twist. So because that's 360 degrees twice. So it's like the profile is twisted. So that's what. And you know, if it's closed, they don't twist it. They ring, they don't squeeze. This is squeeze, this is ring, yes. Sir? No, this is for this thing, this iron suspenders they used to put in building. Those beams, yeah, those things you just ring them. Put them, that's you put them in the wall before you pour the cement. So they're always twisted. So, or you want to make a screw or head of this stuff. So you use a profile, a straight line, and then you now twist it. Huh? Mix up. Mm. I've never seen when they produce those stuff, but I've always seen those things twisted. So I don't know. I think maybe that's just how. Uh, yeah, whatever. So, all right. So basically, uh, that's the sweep. So, and one thing we should note is it doesn't necessarily have. They don't need to be close together to work. You don't have to actually put it by the tip. You know, the way it's arranged, and you think, okay, it just is because it's close, that's why it's working. So what if I want to dip it on this? I can carry this and sweep along this. It doesn't need to be close. Important thing, AutoCAD did not say specify the distance. It just said pick the object. So if I sweep this, if I carry this, I press enter and carry this, it will sweep along that one. So it doesn't care the distance. It just knows that you had picked the profile. Now you are picking a path. So it doesn't. It's not how close you bring it to that will make it work. The only one that works with closeness or proximity is this revolve. It needs to go around an axis, so it needs to have a central point, right? And rest extrude the one. Okay, that's that's okay, right? Okay. The last one is loft. Yes, loft. Yes. A loft is a laughter that came after a long time ago. So I laughed at him. No mind you. so, so um, loft is one of the nicest ways to build something. Yeah, but sometimes it can be tricky. So I actually created a just open. There's a file I did there. There's a file I did where we have those guys. So it's the one I put loft there. So just loft. That's the name, loft. So it's in that same folder. If you do open, it will open where you were recently open. So loft. So just open the loft file. We just have um, a circle, polygon, and circle of different sizes. So if you want to create your own, no problem. You can still create at the like can create if you like create a rectangle and can create another rectangle, uh, probably create a circle. Okay, so can now uh, probably raise them up in space or in time or whatever. All right. So hello laughter. What's up laughter? Um, now let me do this guy next. Don't worry. So you can, if you want to create your own, it doesn't matter, just create a log. But let's me work with this one first. Imagine you had a Coke bottle and you wanted to draw the profile of the Coke bottle. You know, like how we did last in that Illustrator and the rest, you use your pencil and sketch out profile of the bottle. Now with a loft, you can actually just create circles and place them at key points of the curves of the bottle and loft is it will generate a surface from the first to the last point. So if you pick the loft now, for instance, it selects cross sections in lofting order, like I said, in the way you arrange them. If you do it in another way, it will bring out a result that you may not like. So let's say the order, this is the first object, this is the second object. It creates surface that connects that. And then this is the third object, it creates surface. So it makes that shape. Once you are done, obviously you press enter. Then you can now say cross sections only or path or guides. Path is if there was actually a path you were lofting across. So, but I'll just click enter again to allow that. So this is the loft. Let me try. It is not a trophy. Not a trophy. Don't trophy. Don't trophy like ice. It's not trophy. So that's the loft. Okay. So yeah. Doesn't. So that's loft too. Very general. Now, if you pick from up downwards, it will still loft. It will still loft. Okay. But if you pick like this, pick like this, pick like this, eh? It will loft weirdly. So because it picks, it's following the way the object should, what's the word? It's following the way the selection is made, right? So you pick the first, it goes, and it connects the next one. So if they are weirdly connected, you will have a weird looking shape. If you do a loft with something that is not visible, just like you were trying to do with the revolve, AutoCAD will give you the result it wants to give you. It will not allow for your whatever. Yeah, so what the rectangle will create. Okay. So I mean loft is one, two, three, enter, and then Rectangles one will be one, two. So this will create shape. That's not. I don't understand. so, so, so that loft, just like with the other stuff that we've been doing, paying attention to this guy, we have modes, right? Joining by points, multiple edges, or selecting a mode and choosing solid or surface. So still those same kinds of voila. But then once you create your loft and you are done, okay, and you press enter, we now have all these other options too: guides, path, cross sections, or you go to settings and change some things. Click on this, it will open those options in case you didn't have them before. You click on the blue arrow, it will show you another set of options. Now, what these options are: normal to all sections, normal to start, normal to end, and let me see if I can get this guy in a good position. So let me zoom in. So if I do, looking at the way it's curved, right? If I come here and do normal to all sections, you see it changes the way it curves. Because based on the normals of where the object is facing, it's trying to round off itself. Okay, if you do normal to start section, this was the start section. So only the start section will have that round effect, not the end section. And the reverse of the case. So normal to end section to round off the end and straighten up the start and stuff. So depending on what you want, and then if you do um, smooth fit or all this uh, funny looking like these draft angles, you see this points here, you can click on this arrow and adjust the way you can adjust the way you can adjust the way this guy behaves. Then this one, you can change these guys to, so you can see, you see what I'm doing, right? That one is up to you, not necessarily making a couple. So mm, so you can now cross sections only and so and create this kind of shape. Okay, so that's how loft is used. You generally draw out profiles, a lot of profiles, and then run them across themselves. Okay. If you mm, why the form that you've been using since Illustrator, how that will not be going to be? So are we good? Okay. So I should take that as a maybe, right? Still. Okay, let me do the sweep again. So when you select the sweep, you pick the sweeping object, that is the profile, right? And enter. There's been, let's say we're not changing anything, so I just press enter. The next thing AutoCAD is telling you is to pick the path to sweep. Once you pick the path, it will sweep itself. You don't need to do anything, it will just sweep itself. Has it has it responded? It's responded, right? Okay. Are we all good? Yes, we are good. We are goodest. All right. Oh, okay. Let's do let's do a little exercise. Kilo day. Hmm? Kilo day. I'm looking for something. Let's come to the file that we open and look for Boolean tools. They're not bully. Boolean tools. Boolean. You don't need to. No worry. Boolean. 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 Boolean tools are tools we use to combine. We've used Boolean tools since semester one. We use them as pathfinders. We use them as all those union. What we use them in Figma too in semester two. In semester two, they even taught you Booleans in JavaScript. We use them in Animate. Then semester three, we've used Booleans in After Effects. We've used Boolean tools. Okay, example that is, you remember union, subtract. That is, those are Boolean tools. So, since the English is looking like French. All right. So these are common shapes. Um, these are common shapes. The cool thing we will do tomorrow is that we will learn to draw the shapes. A lot of drawings. We'll carve out a lot of drawings. There's a basic drawing that they always give everybody in technical drawing. We are going to draw that drawing. All of us are going to draw it together. And then, not that one. I'm talking of 3D. All right. So after this, I'm going to just briefly talk about these line tools, but I'll advise you watch the clip. Edmond, quiet. So now we have these three objects, but I want to use Boolean for each of them. I want to do, I want to connect, these are three different objects, or four, there are four, yes. These two are the same, just duplicated. This one is one, this one is one. Looking at this already, you can already tell how it was created, right? This is a rectangle, this filleted. They added a fillet, and then this is obviously press pull to create that hole, right? Same thing with this one. This is a rectangle, press pull, create hole, and stuff like that. So the first Boolean tool that I want to use is the one that will connect two of them, all of them together. There are four objects here. It's one, two, three, and four. So if you are already in your 3D design this thing, so this is where we have our tools. This first line here, that first line. So we have union, we have subtract, and we have intersect. So I'll start with union since I want to connect these guys together. So I will use the selection mode that makes me select everything without engrossing all of them in the rectangle or in the marquee. Which direction am I dragging, left or right? Make that selection. What's the color of the selection? Wait, let me ask you like, like this. I'm going right to make. Yeah, let's select everything. Yeah, sure. Okay. What is the color of left to right? Do we all agree? He said left to right, blue. That will make me select. I don't need to put everything inside the box, but once it crosses, it's going to select. That's select. Doesn't once I drag it, I don't need to engraph the whole object, but it will select everything. There are two selection techniques of dragging that I taught yesterday. One needs you to pick up everything. Everything has to enter that box. The other one doesn't need to pick up everything. It just picks. So, so good. So it's green. Yes, that is what I'm saying. That is. Okay, mhm. So I was asking. I want to pick. I want everything to enter, but I don't want to. I don't need to touch the whole. I don't need to engraph all of them. So the green, yeah, going from right to left. So as long as the line touches the object, you can stop here and just select it. So for the blue one, it will only pick whatever is fully inside box. So, so let's go green. Let's go green. Okay, so to do union, simple. Just click on it, union, and it becomes the object. So let's see, 1, 2, 3, 4. These guys, bam, and it becomes one object. So that's union. It has made all of them one object. So I could select it, or I could just pick the union and select them later. So that is it. They are now one object. Now for this one, these are these are multiple objects. These two objects are the same, just that this one is lifted higher and taken more back. So it kind of creates a like a cut through. And then we have these cylinders that are crossing underneath this guy. So I want to use this one on top and these three cylinders underneath to cut holes in this one. So the object is subtract. So you pick subtract and AutoCAD asks you to select the object. Okay, and then it asks you, what is it, the objects to, let me do that. Subtract 1, 2, 3, 4, and oh, I did the wrong selection. I need to divide. Select and 1, 2, 3, 4, and cuts a hole. So it uses this top one to cut a hole here, uses the bottom ones to cut a hole on the bottom. So just like with the other tool and the sweep tools, you want to select the main object that you are keeping first. So subtract, select objects, you select the objects, then enter, and then you now select the objects that are being subtracted. So if this, you don't need to press shift, just select them. Once you are done, you can now press enter again so that it cuts open the hole. Okay? Yes, you select the object that you should maintain first, and then you select what should cut through next. Mhm. Okay. Now the last one, we use the last Boolean tool here, which is intersect. And the concept of intersect is where the two objects collide, what will remain is just that point that they collide with, not everything else. Everything else goes except where they collide. So here I have two objects. I have two objects here. This curved, kind of curved plates, and then this box here. So, so I want to intersect between this and enter, and now I have these holes that are appearing within this guy because the holes were on the rectangle or the box on top, and the curve is left where the this guy and the rectangle met. So that's intersects. So in architectural drawing, most time when you are trying to create things like hinges of doors or metal plates or cars or whatever it is, you actually don't create these guys from scratch. You just create multiple objects and then you use them to cut themselves. Like I said, drawing in AutoCAD is not like drawing that we used to do. So everything you do, most times you have to connect two or more objects to cut out the shape you are looking for. Or you have to draw some shapes on top of another shape and now use that to cut a hole through. It's not the kind of modeling that is revealed onto us. So this is how we will use Boolean tools, yes? I don't understand why. Okay. So this is a box that has holes, right? Press pull. And now this is just a flat plate. It doesn't have any holes, right? So now I want to cut across it. So I use intersect, select the two objects. Doesn't matter which one is selected first. Once you click enter, it will make those cuts for you. So generally, like now, if you have a box like this, and then you have a cylinder like this, and probably a wedge. Okay. So if I'm trying to use this cylinder to create a hole on this wedge here, let me just show you how those things are done. So I'm trying to use this cylinder to create a hole here, right? Okay. So which one will I use? I will use the subtract, right? So I select the wedge first to keep, and then I subtract this from the wedge. So I carry, subtract, select the wedge, that's what I'm keeping, and then I select the cylinder and cut. So it makes that hole, right? Good. So this is another cylinder. So let me rotate it, 25 base points. Um, there's my gizmo. Right, so rotate it along this axis. Okay. Then I'll move it in here. So I now probably make a copy. Yeah. I didn't even know what to answer. Yeah, control D, okay. I said drawing here is not like what you know. Okay, so let's say I just have this weird one, this weird bars here. So you want to cut through this guy, right? So let's say subtract, right? Select this one, subtract, and select one, two, three, four, and subtract to create that kind of design, right? So generally that. Then if you wanted to do something like intersecting these two, between this one and the wedge, I'll bring it here. Come on. So now to intersect so that only where they cross over there will be life, right? So you intersect, you select this one, select this one. So whatever was left there between them, that's where you now have that funny looking concept there. So that's how you want to model some kinds of engineering objects. You need to connect objects together and cut them through themselves. So it's just basically that. Okay, so I'm going to allow you guys to go and play around with those. Um, we have class tomorrow, so we are going to work on more drawings. Um, one of the drawings we are going to draw is uh, what is the I'm going to draw these things. See them? So you already have the I think I sent you inside that is in the picture is with you already. So you can go through the picture and observe. Yeah. Can go through the picture and observe. Why you running into it now? Ma? Where is it running to? Eh? He asked, I have asked him where it's running to. These figures, they are sculptures. But this is the drawing. This is the drawing of these guys here. So this is it. You're going to draw this, and for the other one, not you. This one, this is it here. Hmm? Where are they? What are they? They are devices. You've not seen something like this before, like a wedge. They want to bend some iron, all those kind of things. They lie the thing on this part of the body there, and they use something to tight it, and now bend all that kind of stuff. But generally, it's not it. It's a combination of it. But most times, when we want to see that you understand, especially if looking at this guy, you will see that you have to use 2D objects to cut holes into 3D objects and stuff like that. So the idea is to see whether you really understand using the dynamic UCS or using the view plane UCS or the world the WCS to draw these things because like for instance you see this wedge here. This wedge is not drawn like a normal wedge that the wedge tool. You construct it from a triangle or a polygon triangle that you draw on a view plane and then extrude it. Then this one's it's a circle, there's a rectangle, there's a circle, then you now cut them so that it brings out these shapes like this. So that's what we're going to do tomorrow. So sometimes in architectural drawing or engineering drawing, they give you some very weird designs just to be sure that you understand how to use it. So the designs just task you because now you have to figure it out. What are the shapes you use to get this? So that's part of the training. You have to figure out what you would use. In 3D modeling, just like in 2D drawing, if I give you something to draw, you have to figure out what you need to use to achieve that drawing. It's not every 2D drawing that you actually draw with pen or brush. Yeah, drawings you just use shapes and create. Because mix a lot of shapes together and boolean all of them. But you have to know what to use. 3D drawing, on the other hand, you are basically not drawing like 2D. You are sculpting something from your mind. So you have to be able to look at something like this cup and figure out how you achieve this design from a simple cylinder. So that's part of the training process. So here in AutoCAD as well, as I give you like these pictures, I'll just give you the picture and you will determine what will be used to achieve it. These are the measurements in units. So this is a radius of 48, a radius of 48, a height of 64, a, then you have the breadth of 64. So this is a perfect square. Then this one is 96 by length or by depth with a height of 16. This distance from here to here is 16, from here to here is 16, from here to here is 16. From here to this center of this circle that you draw wherever here to get this arc has to be 20. The height here, the width here, you have to determine this height, this angle, by this other square's height, which is 28. So whatever you have here has to connect to the top of this and to the bottom of this, but with a width of 12. This distance must be 22. This must be 8, 8, and 24. then this is 16. So all together, 16, 8, 24, 28, 20, all this size should get you to 96. Then this one, see, everything should get you 64. Otherwise, this drawing will not come out. Good. So that's the level we are in now, the kind of drawing we are drawing. Same thing with this. You have circles and whatever shapes you add. So the first question you ask yourself is, how is this shape designed? Whatever wisdom you want to use, just know that the inner radius of this, the inner diameter of this circle is 24. The, the one of the outer circle is 42. The height of the circle from the circle to the height that is to the top here is 24. The distance from from the center of this circle to the center of this other circle is 100. This coverage here, from here to here, you will have to determine that from these centers. So you have to do your mathematical calculation yourself to know what the height or the length of this guy from this radius. So that means you have to subtract from this radius to this, from this to this, which is not hard actually. It's just simple math. If the diameter of this circle is 24, that means its radius is 12. The diameter of this one is 42. That means its radius is what? What is half of 42? Hey, Jason. 21. So you now calculate 12 of 21 for this one. You now calculate this one's own too. Then you now subtract it from 100. So whatever figure you get, that is the length of this thing, this height that 60. So then this one is a tangent of 64. This circle, that's the diameter. Ma, what? Thank God, thank God we have calculators on our systems. So we are going to calculate. But that's what we are going to do tomorrow. Together, yes. No, I'll just be asking you like the way I'm asking you. You'll be drawing. You'll be the ones to tell me how we will come up with this. Like I said, it's part of the training. Look at the design. How do we come up? What do you think we will come up with to achieve this? We've been training for this since semester one. Semester one, the same thing with Illustrator. I will bring out a flyer, I'll bring out a schema, tell you to look at it. What do you think you will use to get it? If you don't have that creative eye to look at something and determine what you would use, then you cannot be a creative. Being a creative is not by name. It's by actually using your brain to be creative. So if I tell you, I want us to design, this TV is very easy. I want us to design this microphone with this pin, and I drop it here and I say start modeling. It's not me that come and tell you, okay, go and carry, you go and carry it. You have draw this one, you go and carry this one, come and use it. No, bro. If you cannot identify it, then you're in the wrong place. So looking at this, it's easy to know what is used. We have done press pull, we've done extrude, we've done sweep, we've done loft, which other one again? We've done the basic geometric tools of cylinders and the rest. So when you look at these things, you should just know. But one secret I will let you know is when you are drawing architectural drawings, mostly all these kind of drawings, you never start with a 3D object. You start with a 2D object so that you can collectively measure it well, get the all the radius and all the length and all the width. Otherwise, you get one chance. All right. So gear up for tomorrow. We are going to do some work. Please, everybody must be involved. Yeah, just get involved. Depending on your success of tomorrow's class, we'll know how fast we can go. So I'll know whether when we're coming back next time, we are going into the next module. Hmm. So we have done with module 3. We are going to draw as transforming 3D geometry to get this thing. All right. And then these ones are, these blocks attributes, this class, you can do it in 10 minutes. You can do this in 10 minutes. This number 4. You can teach this in 10 minutes. You can do this in 30 minutes. So this 4, 5, and 6, we've already started doing this one, creating surfaces from 2D profiles. That's using the NURBS models. The only one we've not done here is mesh model. We've created solid models. We've created solid objects. So that is stuff in the lab. So let's sit up. Like I said, we don't have much time, and I want us to be done so that we can do one more live. So that's all for today. Thank you.